In an earlier example, we met Heike, who is lending her money to a banking institution. She receives compensation in the form of an interest payment on her savings. The bank can afford to pay her this interest and still make a profit because they lend this money to others at a higher interest rate. In England, as in many countries, a high proportion of people prefer to own their own home. Nipan and Hettel wish to buy a home, but it will cost £100,000 more than they have. They'll need to borrow that from the bank.
Is that right, people?
Jamie, hi, nice to meet you. So, how can I help you?
Actually, we are looking for property near city centre, and we also need a mortgage of £100,000. So,
Right,
what are
okay.
the interest rates right now?
Well, obviously various different mortgages available, fixed rate tracker, and we have a private finance division who can certainly advise you.
Let's assume the best fixed rate loan they can find charges them 10% interest over 25 years, during which they must pay back the loan and the interest. Nipan and Hettel would like to know if they can afford this. How can we calculate their exact monthly payment? You might think that Nipan and Hettel will be charged 10% of £100,000 every year for 25 years. But this isn't so, because they make repayments to the bank, and as they do so, the amount they owe will decline. They'll only be charged interest on the declining amount that they owe. The mathematics of finance will help us to calculate their monthly charge and make reasonably straightforward and apparently very complex calculation. We have a couple here taking out a mortgage for £100,000 and paying an interest rate of 10%. Their mortgage, typical of some but not all, is that they repay a sum monthly, but interest is charged annually. Given this, we want to find a monthly amount that Nipan and Hettel must pay to clear the debt at the end of 25 years. The problem is that the debt is reducing each time a repayment is made, but interest is being added to the remaining debt. In their case, the debt is £100,000. The interest is 10% fixed for the life of the mortgage. So we can approach the problem like this. At the end of year 1, the debt is the original amount, 100,000, times 1.10, because the interest is 10%, less 12 times x, where x is the monthly payment. That is 100,000 times 1.10 minus 12x. At the end of year 2, they now have a debt which can be represented as follows. 100,000 times 1.10 minus 12x, that debt that they had, is now multiplied by 1.10, but we now have to subtract the 12 monthly payments, so it's minus 12x, which we can rewrite as 100,000 times 1.10 squared minus 12x times 1.10 minus 12x. Let's see what will happen in one more year. They'll have this debt multiplied by 1.1 and reduced by 12x, which gives us 100,000 times 1.10 squared minus 12x times 1.10 minus 12x, all times 1.10 minus 12x, which we can rewrite as 100,000 times 1.1 cubed minus 12x times 1.1 squared minus 12x times 1.10 minus 12x. For each year, we multiply the debt by 1.1 and reduce it by 12x. The effect is to raise each term by a power. So after 25 years, we have 100,000 times 1.10 to the power 25 minus 12x times 1.10 to the power 24 minus 12x times 1.10 to the power 23, etc., down to minus 12x times 1.10 squared minus 12x times 1.10 raised to the power 1, if you like, minus 12x. Now that first term is easy to solve. 100,000 times 1.10 to the power 25 is 1083470. You can check that with your calculator. Now look at the second term. This has a geometric series that can be calculated using the formula a r to the n minus 1 over r minus 1, where r, the geometric ratio in our case, is 1.10, n, the number of years here, is 25, so that's 1.10 to the power 25 minus 1 over 1.10 minus 1, which gives us 98.35. So establishing the monthly repayment necessary to clear Nippen and Hettel's mortgage, the term outside the bracket, the A, is in our case 12x. So we need that 1083470 minus 12x times 98.35 equals 0 if the debt outstanding at the end of the term is to be nil. Now to solve this we need x to be on the left hand side. So rearranging, we have 12x times 98.35 equals 1083470. So 12x equals 1083470 divided by 98.35. So x is 1083470 divided by 98.35 times 12 equals 918.04. So our couple are committing themselves to a monthly repayment for 25 years of £918.04. We worked out the formula and we solved it for a couple borrowing £100,000 for a term of 25 years at a fixed rate of 10%. After 25 years, they'll owe nothing to the building society. Whether it's all been worth it depends on a number of things, including what they could otherwise have spent the money on in renting a place, and also what has happened to the capital value of the house that they've now acquired.